Hello everybody, welcome back. Today we're continuing with 2.1, the tangent ratio, and we were on example 3. This example is also found in your textbook. It says using the tangent ratio to determine an angle of what's called inclination. If you don't remember what an angle of inclination, you can go back to your booklet a few pages back. I think it's right here. So angle of inclination is what it makes with the horizontal, and then how it increases above. So basically your roof line with the horizontal. Okay, so let's go back to the question here. It says the latitude of Fort Smith, Northwest Territories, is approximately 60 degrees. Determine whether this design for a solar panel is the best for Fort Smith. Justify your answer. Okay, so we're going to look at the solar panel and check out what the angle of inclination is, and we're going to do that using our trig ratio, and then we'll see if our panel is around the same degree. If not, then it's not a good design for the panel, right? Okay, so we'll do that now. So what you want to look at is you have your I call it the shorthand formula, tan of theta. So tan of an unknown angle is equal to opposite of adjacent. So you'll notice if we drop a vertical line here, it creates it's actually called an altitude, and it creates a 90-degree angle here at the roof. So the house, obviously, the roof line has a span of 24 feet from here to here, so halfway is 12, and then the height of the roof truss is 9 feet. So that's how we're going to determine our angle. Okay, so what I'm going to do is I'm going to pull the triangle out and label it for you. So I've pulled the triangle out. You'll see that it's right here. It comes out here. I call it ABC. You can call it whatever you want. It doesn't make a difference. So we're looking for this angle here. The angle of inclination is the horizontal with the incline. So that's going to be called, instead of theta, we're going to put C, because theta is just an unknown angle. And C, we'll plug that in. The opposite side here, obviously that would be 9. So this is where the 9 goes. We don't need the units. As long as the units are the same, we're fine. They're both in feet, so we're good. So what I mean by that is one of them was meters and one of them is feet. You have to obviously make them the same. You can't just plug the numbers into your formula. It wouldn't make any sense. So there's your angle, and then what we do next is we put the inverse tan in. So I'm going to steal this again. Alright, we say that C, or angle C. Oh, sorry. Let's get a new insert. I do apologize. So C is equal to the inverse tan of, brackets, of course, a fraction. Right. Okay. So this is what we do when we're trying to find the angle. Remember, take the inverse of that. We get 9/12. And so that's going to mean that angle C angle C is equal to that, and we just calculate that on our calculators. So inverse tan of 9/12, 36.869,897.65, and so on. It says determine. It didn't really say what to round it to, so I'm going to go to the nearest degree. Steal that from above. Angle C is equal to 36.9 37. So 37 is fine. 37 degrees. I'll just go to the nearest degree. So to answer the question, the angle of inclination of the solar panel is about 37 degrees, which is not equal to the latitude of Fort Smith. So this design is not the best. So I would say it'd have to be somewhere around 60 degrees. If it was 61 or 62 would be fine. You know, anywhere between 55 and 60 really would be okay. Not perfect, but fine. So that's how you would answer a question like that. All right. Bring the rest to check your understanding questions right there for you. It's a similar question, and I've given you a diagram on your sheet just so you can take a look. Okay. Next we have example 4. Example 4 says using the tangent ratio to solve a problem. This is the old-fashioned ladder question. They've been doing the ladder question for years. So I will draw this diagram for you, or what the triangle is going to look like at least. So when it says use diagram for visual, I think that's important. So there's your diagram here. We'll talk about it. It says a 10-foot ladder leans against the wall, so this would be the ladder, this would be the wall, and this would be the ground, assuming it's going to create a nice right angle. And the ladder is 4 feet from the wall. What angle to the nearest degree does the ladder make with the wall? Use a diagram. So it's very similar to the other questions. Again, we're using the tan ratio, and we'll go from there. The issue is we don't have this side PQ. If we're looking for angle R, we need to have the opposite and the adjacent side. Right now we have the hypotenuse, so we can find this. We're going to learn a ratio that works for this, and that's called sine and cos. We're going to talk about those later on. But right now we don't have that information, so we're going to have to go the old-fashioned way and use, you guessed it, Pythagorean theorem to get that opposite side PQ. So let's do that now. So we're going to insert an equation of Pythagorean theorem. Alright. So there's our Pythagorean theorem, right? I'll make it red because we like to do their answers. So we know that 10 squared is equal to, we don't know PQ, side PQ squared, and we know our Q is 4. Okay, so I skipped that first step, but it's just simple Pythagorean theorem. You guys know how to do that. So we're going to solve, so we'll square those, we get 100, we square the 4 and we get 16. Then you're going to subtract 16 from both sides, as you guys are aware, and you're going to get 84 is equal to PQ squared, and then you take the square root of both sides. Insert the radical sign, so we get the square root of 84 is equal to PQ. And I'll just leave it like that. I'm going to use that square root of 84 as the opposite side. I would literally leave it like I said. You can put up your triangle if you want. It doesn't matter. That's this side here. Okay? So, Pythagorean theorem, that's old news. Now we're going to get what we need now. That's the tangent ratio for the angle. We know that the tangent of, I'll go with the definition here. So we'll go to our formula sheet. You guys probably remember this by now almost. We go tan theta is equal to opposite over adjacent. Right. We're looking for the angle R, so we'll go tan R. Opposite is what we just found. Opposite is that square root of 84 that we found, and the adjacent side to angle R is 4. There we are. Okay. Let's get the inverse part. I'll steal that from the previous question for a minute. Change it to R, obviously. Replace that fraction with a new one. So the angle R is equal to the inverse tan of the square root of 84 divided by 4. Make sure you close your brackets. When I do that in my calculator, I guess divided by 4. That's right. Make sure 4 is not underneath the square root. and I got 66 decimal 4. All right. Let's do this thing again. Angle R is equal to 66 decimal 4 21 821 52 and to the nearest degree it says. So that's easy enough. And we say that it's 66 degrees. So let's steal a degree sign of what does. My bad. 66 degrees. And that is the final answer. Okay. 66 degrees. So, to what is the number of the ladder make? So we can answer with a sentence. Right. The angle between the ladder and the ground is approximately 66 degrees. There's a check your understanding to go with that. It's a support cable question. I should have the diagram in there. If I don't, it's not a big deal. You can draw one. Okay. So no, there's no diagram, but just draw a little diagram for yourself. Okay. Just to get an idea of what it looks like. It's similar to what we just did. And that's on page 6. So that is the final example for chapter 2, section 2.1, the tangent ratio. Questions that I would like you guys to work on pertaining to that is numbers 3 through 6, starting at page 75, 3 through 6, 8, 10, 11, 13 through 16, 19, and 20. Thanks, everybody, and we'll talk soon. Again, when we do 2.2 is our next section when we are talking about using the tangent ratio to calculate lengths. Thank you very much, and we'll talk again soon.